This video is going to be all about soldering, and I'm going to go through doing surface mount soldering of the components for the design board. But I wanted to talk briefly at the beginning about just some background information and safety information. So in this video, we're going to be using solder paste, and solder paste is fairly simple. Solder paste is just little tiny balls of solder, and in our labs we use entirely lead-free solder, but that doesn't necessarily mean it's safe. It doesn't mean you can just eat it. But they're little tiny balls of solder that are suspended in flux. And for people who don't know solder and flux, solder is basically a metal that is meant to bond two different metals together. And the way we use it in electronics is it's generally a low melting temperature metal. And it's also used in plumbing. It's very similar in plumbing too. But usually these are a metal that will melt at a lower temperature than the two metals they're bonding together. And so this bonding metal, which forms both a mechanical connection and an electrical connection and a thermal connection, I say both, right? So you can heat up a component, and then only the solder that is supposed to bind the two things together will melt. Everything else will stay solid. And one of the issues, though, with heating up metals is metals readily react with gases in the air, so oxygen being the biggest one. And so these metals, usually when they get heated, they'll form an oxide. And flux is something that, among other things, is used to prevent metals from forming this oxide layer. Because when metals form this oxide, the oxide is quite often brittle. It quite often doesn't bond very well. And so the flux paste is usually kind of a weak acid gel, which prevents the formation of oxides. Flux paste also provides a thermal connection. So it's also something where at the tip of a soldering iron making contact with a solid piece of metal or a solid piece of solder has a very small contact surface area. But flux kind of helps spread that surface area out. It also, once the solder starts to melt, the flux sort of forms a little sarcophagus around it that protects it from oxygen, and also provides kind of like a thermal blanket. It has really beneficial thermal effects too. Well, solder paste is little tiny solder balls that are suspended inside of this solder flux gel. And there's different types of solder paste. There's leaded solder paste, which is really important to note, lead versus lead-free. One big danger is if people do this at home, it's very possible that people will buy lead solder paste. Lead solder paste is very dangerous. So it is, especially if anybody living in the home is under age 14 or potentially could be under age 14. Lead is just really bad for people who have developing nervous. It's bad for everybody, but particularly people who have a developing nervous system. And so we don't use lead at all in our labs. But if you're buying this at home, you want to try it out for yourself, I would strongly caution against using leaded solder paste, especially if there's people in the house or in the building who might be under age 14. And the biggest concern with solder paste, it's much worse than normal solder because if you look at this image, it has these suspended solder balls. There's a massive amount of surface area. So like if you just ate a lead fishing weight, I don't recommend it, but if somebody just ate a lead fishing weight, or you found a lead tire weight on the side of the road on the curb or something, and you ate it, only a small portion of that lead would actually dissolve into your body. But if solder paste, these little tiny balls, massive surface area, a lot of this is capable of dissolving and being absorbed by your body. Very toxic. And also this paste, right, it's easy to get all over the place. It's easy to smear it. It's easy to make a mess with it. And if you're talking about making a mess with something that's leaded, that's a real danger. You could have a little smear of it somewhere, you don't even see it, and then some kid walking along, wipes their finger on it and then licks their finger, and then you're in real trouble, or they're in real trouble. So I'm trying to caution people. It really is important to be safe with this stuff. I always tell people, you should be washing your hands beforehand for the COVID precautions anyway, but I always recommend people, after soldering, regardless of whether you're using lead-free solder or not, wash your hands afterwards. And really do a good job of washing it, because this solder paste can be kind of a greasy, it's almost like anti-seize grease, where I don't know if anybody's ever used that, but that anti-seize grease, similar thing, metal suspended in grease, and it's very difficult to clean up. And so scrub well, use alcohol if you have to. Use whatever it takes to really clean your hands up, but you want to make sure to be safe. Okay, I've spent enough time talking about that. So we're going to go over a couple different types of soldering, and the goal here is I want to give people as many options as possible for soldering their board. Some of it you can do at home, some of it you can't do at home. I haven't personally done the skillet reflow before. I'm going to try it, but I'm going to kind of show you how that's possible to do also. But the three types of soldering we're going to go over in this video is just normal soldering with flux core solder wire, soldering with solder paste with a hot air gun, soldering with solder paste with a soldering iron, and then touching up any of those techniques that we use. There's usually going to be bridges and things like that. So then also going over how to touch up the design. Before you get started, though, the biggest thing that causes mistakes for people when they're doing reflow soldering or this sort of surface mount soldering is not being prepared in the first place. So the biggest keys I would say is, one, make sure you have your schematic printed out and ready to go. Make sure it's clean. So it's easy when you're doing a design to say, oh, I'm going to put a 1 mega ohm resistor here, but later on I'm going to change it to 100 kilo ohms, which is something I actually do in my schematic. You can say, that's the same footprint, so no reason to change it, but then you forget about that. And then you have your schematic printed out, and you're looking at a resistor on the schematic. Oh, R17, 1 mega ohm. You take a 1 mega ohm, you put it in there. Well, if you had actually meant for it to be something other than 1 mega ohm, it's easy to forget that. So check over your schematic. Make sure all your values are correct, what you want them to be, before you get started. The other thing is components, right? Make sure all of the components you're going to use, make sure you have them beforehand. Make sure they're labeled. One thing I like to do, if I have a lot of loose surface mount components, I like to tape a piece of paper to a table, tape it to a table, because otherwise you get those little components on the paper, and a breeze comes by, or you brush it with your hand, and everything gets lost. So I tape a piece of paper to a table, write on the piece of paper 10K resistor, circle it, put my little bundle of 10K resistors there, whatever you need to do to make sure that you keep everything neat, organized, sorted, ready to go for you. So when you're doing this, assembling your board is as easy as just grabbing a part, putting it on, doing the soldering, moving forward. Okay, I'll probably add a couple other tidbits, but I just wanted to have this little tiny mini lecture beforehand, and then we'll get going with the soldering right now. I think I'll probably switch to an overhead camera for the soldering, so I'll be narrating it, but you probably won't see me for this next. A quick overview of these low-cost reflow units, these low-cost hot air solder units. These are, you can find something like this for $60 or so on eBay. They actually work very well, especially the newer version. I think there's, we got several of these that we bought for your labs here. This is the one I like, the 853D. What I like about it is, and this is not one of those, but what I like about the 853D is it's got sort of an automatic, when you put the hot air gun back on the stand, it starts a slow cool down process. It helps prolong the life of the device. It doesn't leave the hot air on all the time. But these units, before I get too far, there's basically two things here. These types of units have a soldering iron. The soldering iron unit, which is not connected right now, but that's just a wand that the tip of it gets hot, and so you physically touch the tip to something and it melts it. There's also a hot air gun. So these guns have a heating element inside of them, and they blow air through it, and so what comes out the nozzle is a stream of 300 to 450 degrees C air. Now that is very hot. So that is not 300, or that is not 400 degrees Fahrenheit oven temperature. That's 400 degrees C. So this is like instantly burn you type hot air coming out of these things. So don't, be careful what's at the other end of this tip. A lot of times people will stick this, they'll stick this up next to a wall, and they'll have this hot air gun pointed at a wall, and you can cause fires. So you want to be really careful with these sorts of things. And operating them is fairly straightforward, but important to note. It's easy to damage these, especially these older ones. The newer ones are much better at having some safety features that prevent their destruction. But you can damage both the devices and your board. So really the only thing in the soldering process, the only thing that will ruin a board or ruin a component is too much force and too much heat. So a lot of students, they have this tendency they come in here and they go, boom, just crank the dials as far as they can, just get maximum heat. don't do that. So you only need maximum heat. Sometimes you'll need it if you're soldering something that's like, you know, a massive inductor or something like that, where it just has a huge amount of thermal mass. Then maybe sometimes, but normally you don't actually have to go that far. The other thing is, a lot of students have the air turned down too low. If the air is turned down too low, there's not a lot of air flowing through this nozzle. Typically what's bad is students will have it set at a certain temperature. They'll have it set at like 380 degrees, and they have their air cranked up, and they say, oh, that air is too much air, so they'll go wham, and they'll turn the air off. And the problem is that heating element isn't correcting to that slowdown of air fast enough, so it'll immediately sort of overheat the heating element, and it can cause damage that way. So you want to slowly move the air up and down when you're changing the air on these units. So we can just, to get this started, we can turn this on, and I'm going to set the air to somewhere in the middle. The thing with the air, oh, I told you not to do that. So you see this knob, somebody kind of took a soldering iron to that knob, so it's seen better days, but it's okay. I've got scars too. We're all scarred up here. So generally with these, when you change the temperature, it shows you the temperature set point, and then it sort of shows you the current temperature. So I'm going to set this to about 350. I usually like to start there if that works. So the solder that we work with should reflow at around 230 degrees, but you need air that is fairly substantially hotter than that to actually transfer enough thermal heat to transfer enough heat energy to actually get that melty happening. Don't crank it up to 480. I know these go to 480. You should never have to operate this at 480, so just don't do that. The nozzle size matters, so we have kind of a medium-sized nozzle here. If you're soldering a big part, you might need to go with a larger nozzle. Small parts, if you're trying to prevent hot air from hitting stuff that's next to your part, you can go with a really fine nozzle. Just be careful, always let this thing fully cool down before you take that off, because that end is hot right now, so we definitely don't want to touch that. So right now, basically, we have a stream of 350 degrees C air coming out of this device here. I can, if you're not convinced of that, I can do something maybe dangerous here, right? Maybe 350 C is not enough. All right, without going too far, right? Little burn mark. That's maybe to convince the internet that this is real heat coming out of here. Okay, so that's setting this up. Now this is putting out 350 degrees C. When we're done, we really don't want to leave this thing running hot for a long period of time. It wears out the filament. Usually these filaments are the things that are most vulnerable. So when we're done with it, we want to turn it off. But you don't unplug it, right? You turn it off, and it keeps pumping air until the temperature gets under about 100 degrees C. Sometimes when it's in this cool down phase here, it's okay to just let it go, right? It's just, all it's doing is blowing air across the filament, letting that air naturally cool the filament down. If you want to speed it up, which you normally don't have to do, and normally is not helpful, you can crank the air up. Kind of speeds that up a little bit. You hear that pump sort of straining when you do that. These don't have the nicest pumps. These are usually just the pumps they use for these are just a little piston connected to a solenoid, so they're usually not very fancy. But that is the hot air station. We will use it later, but that's sort of how you operate it. The soldering iron, we also use these Metcal soldering irons, and these are really smart. These Metcals are great. You just turn them on, and then they work. They automatically get the temperature correct. But one thing I want to show you is, look at this tip. If we can get a focus on here. Okay, that's not bad, but it's not a great tip. So you see that tip's kind of a little gnarly there. It doesn't look very clean. It looks kind of like it has a scale on it. This tip is deliberately curved, so if you see that little hook there, that's intentional. It's supposed to be like that. So one thing to note, first thing, so we have a sponge here which can be used to clean the tip. The key thing is always have the sponge be wet. You always want to wet the sponge. So you can see even just wiping it on the sponge makes it look a little bit better, a little bit cleaner there. If our tip is really gnarly, sometimes you have to sort of rejuvenate the tip. So if the tip is really gnarly, there's a little bit of don't, you know, a lot of students just come in here and they start immediately going to the bronze wool here. The bronze wool kind of gives a little bit of abrasive cleaning. The bronze wool is not intended to be a, or the brass wool is not intended to be a, it's not intended to clean solder off. It's intended to provide a little bit of abrasiveness to rejuvenate the tip, so you can see that. If things get really bad, putting this back, if things get really bad and our tip just isn't taking solder, we can also use tip tinner. So if our tip was really bad and we sort of hit it with the brass wool, I'm trying to do this with one hand, it's not working out here. All right. So we hit it with the brass wool, didn't fully get it clean. Then we kind of, sometimes you kind of do extra abrasives on it, but anytime you do abrasives on it, it loses its sort of nice coating there. So tip tinner is a way, and you shouldn't have to do this, but tip tinner is a way to sort of rejuvenate that surface of the tip. And you see it also kind of gets a little solder on it, but so again, this is not something you do every time. This is just an occasionally thing. After doing the tip tinner, we clean it, and then that tip is looking pretty good. So that's looking right about what we want out of a solder tip. Okay. When you get your board from the fab, it's going to come, so these are my boards. It's going to come bubble wrapped in these little collection here. I already ripped mine open. You can see the first batch of your boards has already arrived. So I don't know who's Kai's board here. We got a yellow one, the yellow one. Amelia, yeah, the yellow ones took forever. They were extra delayed. Look at that font. All right, so we got, I don't know if you see yours in here, but this is the first batch of boards all ready to go, but this is kind of what you can expect to see when you first get it. So, you know, rip it open, pull a board out, and then, yeah, then we'll get started. So there's mine, and I'm going to do soldering on this board, but just wanted to show you, typical shipments from China here. So yeah, anyway, okay, all right, hopefully nobody minded all their stuff being on the internet. We're going to get started soldering now. I apologize for the glare. I kind of tried to avoid it, but I can't. So this is my workstation here. We're going to solder a couple components. We're going to solder the smallest component, which is the boost converter. We're going to solder the battery management chip. We're going to solder the USB connector, and we're going to solder some resistors just to show that. So you see these are labeled 5.1K. So these are the resistors for the USB. So these are the components we're going to do. I want to show you a couple other things. We have solder paste here. Sorry, I probably should have gotten a manicure. My hands are all gnarly. I've been working with messy stuff too. So we have solder flux here. Flux paste here. So no clean, meaning that no clean means that after it gets heated up, it's okay to leave. It doesn't, basically it forms kind of like a solid shell. It doesn't form a sticky, goopy mess that has to be washed off afterwards. So you still can clean these off. I mean, these are still cleanable, but basically what they're saying when they say no clean is it doesn't need to go through a rinse process after being used. It kind of, it dries like a kind of a hard shell. And then this is solder paste. So this is the little suspended solder balls. I don't know if you can, I'm sure we don't have enough zoom here to see the actual solder balls. There's different types of solder paste too. You can see solder paste classified as like 4, 5, or 3, 4, and 5 are typically what you'll see. The higher the number, the better the grade. Basically, a higher grade solder paste has smaller solder balls. And that's basically all you need to know is that. And that's mostly important when you're getting to very small scale electronics. Sometimes the pads are extremely tiny and you might only have 100 solder balls on a single pad. And so in that case, it's better to have fine grained solder balls than coarse ones. So, but we're going to get started here. So the first thing I like to do with the board is clean it. So I'm just going to take a lint-free wipe, a Kim wipe, and some alcohol, and just clean this board off. A lot of people A lot of people will do this with flux too, so you can do it with flux. And just to get, but these boards that we had fab, the low-cost boards from China, these have a Hazel process, which is, so this is actually a thin film of lead solder that's on the surface of these copper pads. So just keep that in mind. This is not actually technically lead-free. It's a very small amount though. The amount that's in these pads is minuscule, but it means the pads are actually fairly receptive to solder, so you generally don't need to with these put a layer of to wash it with any sort of flux. The gold coated ones I tend to like to. The gold coated ones I usually like to wipe them down with a thin layer of flux, and we have liquid flux here in the lab. So we have liquid flux like here, where this is a little bit easier. It kind of makes a mess, but it's a little bit easier to just kind of to spread on a thin film. It's not going to be necessary though today. So we're going to zoom in, and I'm going to start with doing a solder paste example. So actually I want to talk about tweezers first. So tweezers are very important. Having a good set of tweezers. What does a good set of tweezers mean? One, it means they're not sticky. So you want them to be clean. So when you touch the tips together, you don't want them to stick at all. You want the tips to be aligned with each other. You want the tips to be sharp. These aren't great. I think these kind of have been bent back into shape. But if the tips are like really misaligned, like if they're closed and they look like that, sometimes you can kind of bend them back into shape or get a new set of tweezers. These aren't that expensive, but you don't want to be fighting a bad set of tweezers. If parts are sticking to them or something like that, you don't want to deal with that. Just get a different set of tweezers. So let's just do some resistors first. So we're gonna take our solder paste, and we're gonna get something like a needle. I'm just gonna use the end. I'm gonna use the end of a cutoff lead. So this had been just a lead off of a component that had been probably like an LED that had been snipped or something, just a little piece of metal. And what we're going to do is we're going to just dip this in the solder paste and just get a little bit here at the end. And now I'm doing this looking through the camera, so it might kind of be not that great. You can do this with an eyeball. It's really nice if you have a microscope for this, but if you don't, you don't. So just hopefully your vision's okay. So all I'm going to do is I'm just going to touch this to these pads. I need a little bit more. And all I'm doing is just touching the paste to it. And I'm going to show you zoom in a little bit more. I can't zoom in a little bit more, but I can do the manual zoom. So you see what I've done there? I've just put those aren't little actually, that's quite a bit of solder on those pads, and when we melt that, those should melt just fine. So when we put these in a hot air gun or put them in an oven or put them on a skillet, that should melt just fine. If you're doing this with a hot air gun, I suggest don't go too far. But so right now we'll take our resistors. So we verify these are 5.1K resistors. I tend to like to use the tweezers. Now, if you're in lab, you're going to be cutting off your own little set of these, so you're going to be snipping off what you need. I like to take the tweezers and kind of peel back the plastic film. So these are on reels. Normally these are robots that are pulling this plastic film back. Oh, and I just dumped a resistor, right? So we want to make sure our workspace is clean and organized, because if we start dropping resistors all over the place, we want to make sure the only resistors in sight are the ones that we dropped. So if you have a messy workspace and you had a bunch of little surface mount resistors floating around or a bunch of other stuff, it's possible to grab the wrong thing. Now you can see, these should be 5.1K resistors. Let's see again if I can. So looking at this, oh boy, can I find it? There we go. You can see every contour of my gnarly hand. So you can see a little number on the resistor. They don't all have that. That's a hexadecimal number, which can be used to find the actual resistor value, just to verify on the surface. I'll be honest, I don't know the conversion. If you want to look up the conversion, I don't know the meaning. What I usually do is I just Google surface mount resistor, whatever this was. This was like All right, yeah, you're gonna steal Steal my phone password now here. Zoom in on my fingerprint here. All right, 69B, something like that. So I would just Google SMD resistor 69B. That's usually what I do. I'm sure there's an easy way that I just haven't ever bothered to learn. But we have these components here, so now what we can do is we can just take our tweezers and put them into place. The key thing here when putting these components on with tweezers is to not smear everything while you're doing this. So to watch where your hands are as you're doing this. So, in my case, I was deliberately putting the tweezers at this angle, setting them down carefully, letting them go. Sometimes if your hand is like over the board and you're kind of smearing stuff all over the place while you're doing it, you can kind of ruin your board design. So all I'm going to do is these two for now, because I just want to show you. So I want to show you, they're not perfectly aligned. They should be good enough. And what I'm going to do now is I'm going to hot air reflow these. So I'm going to hit these with a hot air gun to get them into place. And so we're going to go follow the process we talked about last time. So same temp, same air setting we had last time. You always want to get things out of the way. When you're doing hot air, remember, you are shooting a jet of hot air, so anything will melt. So right now we're on a silicone pad. One thing students do sometimes is they will solder on like the top of like a laminated tabletop, and it will cause the tabletop to bubble up. So it will melt the glue bond behind the laminate on the tabletop and heat it up, and it will expand and bubble up, and then it usually does never go back to where it was. So we're at about 350. I'm not quite sure this is hot enough now. The thing is, though, with these hot air guns, you want to make sure the air is not, if the air is too fast, if the air is too powerful, you can actually blow your part off the surface. But if the air is too weak, you're not actually getting enough air moving. So you kind of want something in the middle. With these, I usually like to move it around. So you don't just want to heat the portion of your board where your component is. You want to kind of get kind of a sort of a little heat around the entire area. If you just heat a little tiny spot of your board, you're going to get massive thermal gradients, and you can crack your board. You can cause cracking, but I think this will be okay. So you see that, what's happening? So this is set to 350, and these can put, whoop, did you see that snap into place? Kind of still going, just kind of give it a little extra time, and pull it off. Set it back down, make sure to always set it in a safe location. Look at that, soldered into place. Now you see there's a little extra, ooh, this is kind of hot. There's a little extra solder ball here. Kind of a little bonus solder. That one wasn't hurting anybody for now, but it could hurt later on. Okay, so see how easy that was? Putting down paste, hit it with an iron. What if things had gone wrong? What if things had been off? Well, it's easy enough to, while the iron's on it, while everything's nice and melty, to pluck something back off. So you can always do that. You can always, while it's hot and melty, use the tweezers and pull something off. So I'll show you that. So go back here, get it all hot and melty again. Pluck it off. And put it back. Nope, did I mess it up? Yep. What I love about reflow soldering is you kind of just have to get it close, and it kind of, right, the solder wants to wet these pads. So the solder really wants to wet the pads. It really wants to bond these together. So, and this is lead-free solder, and it still is this nice to work with when we have flux and when we have, this solder paste. And so these parts, right? They really want to minimize surface area. They want the flux wants to the solder paste wants to cover both the component and the pad. So it's very forgiving in that sense. It's very nice that way. Okay, let's do the USB connector now. So the USB connector, one thing about these is they are a mixture of, boy, my fingernails are gnarly. They say you can judge a person's overall health by their cuticles, and in that case, I am dead. I think I'm already dead. I'm like, I've been dead for 7 years here. My cuticles are ridiculous. My hands are in general pretty bad. I have a lot of injuries on my hands, starting when, maybe someday in another video, I'll see if I remember where the hell it came from. So this is our USB-C connector. It has both surface mount pads and through hole pads. So that's something to note, is we have through holes, these little stubs for mechanical connection, and then we have these little pads for the electrical connection. So we're gonna have to do both of them. We always start with the surface mount. So what I'm gonna do is I'm gonna put this in place in its little holes. So it'll kind of snap into place because it's got those through holes. It'll eventually snap into place. Maybe, possibly. Oh my gosh. I don't know what's happening right now. There we go. Did it snap into place? I don't know what's happening here. There we go. Okay, I had to kind of finagle it by hand. So now it's in place here, and it's a little loose. You can see it kind of wobbles a little bit, and that's okay. So we're going to do this one. We could have done this one with paste. We will do this one manually with an iron. So whenever we're doing manually with an iron, we want to use lots of solder flux. So I'm just going to squirt some flux all over here. You pay a lot of money in lab fees, so you can be liberal with this solder flux. It's okay. So you see I just coated that whole thing with flux there. Okay. Now. So now what I'm going to do is I am going to take my iron, and it turned off. So I'm going to take my iron that we just showed ourselves cleaning. And, you know, I'll do a couple of these with paste and a couple of these with the solder. So this is fine. This is fine flux core solder wire. And one thing I can do is I can put my iron here on the pad, and it can be hard to see the pad through the flux, but usually as soon as you touch the iron to it, it kind of becomes visible. So it'll kind of melt that flux like that. You see that? So it'll kind of get the flux all melty. It's a gel, but it kind of turns into a liquid when it gets hot. So I can put this, put my iron on, just gently touch the tip of the pad here and feed in a little solder. Okay. And what that did, I'm going to put my iron back in a safe spot. So what that did is it soldered that pad on. And there's a lot of solder there. But the good thing is once you get one pad, you have a little bit of a mechanical connection, so it's not going to go anywhere. So once you get that one pad on, it helps. You don't want to tug on this though, because with one pad soldered, that's on the surface of this fiberglass. If you tug on this, it's going to peel that up. So we don't want to put any mechanical strain on this till we get everything soldered in. Okay, so let's do the rest with flux just to show this. And I'm going to show you how messy you can be with this. So I'm just going to take a needle of this flux paste, and I am just going to smear it all over here. I'm going to show you how messy you can be with it, but it's probably, you do want to be sort of clean if you can. I'm going to take the hot air gun, and I'm going to hit this one with a hot air gun. See, it's getting everywhere. It is making a mess. This is probably not good. This could end very badly. We'll see. We'll see. It's a good test. So sometimes it kind of has to burn off some of that when you're doing hot air. Sometimes it has to kind of burn off some of that flux. This is not feeling very hot right now. There we go. So you see it's starting to get melty. That flux is kind of going where it needs to go. It's kind of getting melty. I might want to crank it up a little bit, but let's call that good. Let's take a peek at that. Yeah, it's kind of messy. See, it left a bunch of solder balls because I was did such a mess with this. You know, left flux everywhere. Kind of smeared over that R2. Kind of put a little pad on R3 also. Kind of got a little on there. And this is easy enough to deal with. So one thing we can do is sometimes taking an iron in here will kind of clean this up. So I can take an iron in here and I'll just kind of gently sort of brush. I'll sort of gently brush these, just kind of gently raking these. And as the iron kind of touches the surface, it kind of picks up some of these loose little solder balls, and then okay. Let's take a peek. Looking pretty good to me. I'm a little worried about some of that flux, kind of where it went. Let me just take a peek at this really quick. Yeah, so we got some solder balls kind of hanging out in places that kind of bother me. I got some little extra little floaters in there. And I don't want an electrical short in here, so what I'm going to do is I'm just going to get a brush. I was being deliberately messy with this, but I'm going to get a brush and some alcohol. Whenever you got a problem, alcohol tends to fix it. So you could just put a little alcohol. This is isopropyl. You can't drink this stuff. It'll make you sick. So it's not ethyl alcohol. Ethyl alcohol is the fun stuff. Isopropyl is the puking. Well, I guess they're all the puking type. But all right, so we kind of brushed that off. We'll dab it with a lint-free Kim wipe here. Now it looks quite a bit better now. I'm still not too happy. I still see some solder balls in there, so I might kind of clean this up a little bit more. Okay, now what happened? When I was cleaning this up, look at that, I got a bridge. So, you know, that's pretty common. Usually it happens when you have too much solder on there, which I do. You're gonna get bridges. All of you will get bridges. You're not gonna avoid it. You know, and usually the best way, there's a couple ways to do it, but usually you can kind of get this off. Just put a little flux paste on there, and then give it a little rake. Usually if you just kind of rake it a little bit, it cleans that up. See? So we just kind of raked it, and we just pulled it, and it kind of separated them. I'm going to put it back though, and I'm going to show you another way. It's another thing you do. So I'm going to re-bridge it a little bit, if I can. It can be hard to deliberately create bridges. There we go. So I re-bridged it. So another thing you can do is you can use copper braid. So this copper braid is just a copper mesh braid. And the idea behind this is the solder really would rather be on this copper braid than on our board. So we can, this one, whoever used this before me, kind of left a little goober on there, so we're going to trim that off. And copper's pretty soft. You can cut it with most scissors. And then we're going to put a little flux on this braid. We're going to deposit a little flux on the tip of this braid. And then we're going to come in here with the braid, and we're going to apply the tip of the iron to the braid to the pad. And then you see the braid sucked up that solder, sucked up the excess solder, and it separated the bridge. Here's the problem people have using solder braid. When people are using solder braid, quite often they will apply the heat to the solder braid. Let me just do this deliberately. So they apply the heat to the solder braid. They get it melty, and then they take the heat off, and then it sticks. Right? Their solder braid sticks to the board, and then they yank it, and then they just pull it off. You never want to do that. So you always want to separate the solder braid while it's hot and melty. Right? You don't ever yank onto something sticks. Right? This is not like welding. Right? With welding, when you get the tip of like your welder stuck, you kind of just torque it back and forth and yank it off, and it's fine, right? Because it's steel. This is a delicate board, right? These are delicate traces, sort of delicately mounted to fiberglass. You can't just yank on these things, so we got to be really careful. Okay, just showed a couple examples of soldering there. Let's go to the little one. Let's go to the little U2, which is our boost regulator. So once again, I have my reel of U2s here. Take my tweezers, peel back the paper. Yep, okay, popped one out. And then these are sometimes hard to tell. It's hard to tell where these are. So I'm gonna immediately put these back. If you're in the lab, these will be sort of in their own little baggie, probably individually cut up into singles. So I'm going to immediately put that back in its baggie so I know what it is. Now let's look at this part for a little bit. You're going to get to see my gnarly hands again. Okay. Here we go. Okay, so this right now is upside down. So we're going to flip it. And one thing you'll see if you look at this, looks like it kind of says CKT. You see that little bar on the top? See that little bar? That bar indicates the side of the chip where pin 1 is. And we can always, if we don't know, we can always look at the data sheet for this sort of a thing. Let me see if I can get it better. Yeah, you see that CKT with a little bar up there. I don't mean to shake, but seriously, it's like my heartbeat. This is very tiny. So you see that little bar where the CKT is? That corresponds to where pin 1 is. And if we look at our board, I'm just going to set this back. If we look at our board, we have a little dot for pin 1. So that little dot is pin 1, which means the bar on this chip has to be pointed down. So the bar side of this component has to be down. And right now it is up. Right now it is up. So we just have to know we're going to have to flip that. Actually, I might even just flip it right now. So got the component here. Give it a little rotate. And then we can go back and check, make sure the bar is down. Yep. See, now the bar is facing down. So now this component's oriented the way we want it. All right, let's do this tiny component. Back to my needle in flux. And I'm just gonna, I don't want to do too much for this one. I'm just gonna do a little. I don't want to do too much, and then I immediately do too much. That's okay, because you know what? You're going to do too much too, so I'm going to show you how to deal with it. Okay, look at that. That's pretty terrible. I'm going to clean some of this up. Well, yeah. I'm going to clean. Now, I don't like to use my tweezers to clean this stuff up ever. So we can wipe it off if we want. So maybe I'll just give it a little wipe. We can wipe it off if we want, but that's too much. So now you notice, right? It's not hitting all the pads. It's way too much on the right side. On the left side, it's not getting that top left pad. And I'm telling you, it's going to be okay. So I'm going to show you how it's going to be okay. So put that back down. We're going to put our component into place. Now this is the part where it's probably better to be sober when you do this lab, if you can, if that's not too much to ask. So, I mean, well, of course you should be sober for safety, but I mean, like, don't drink the night before the lab, because if you try not to have too much caffeine, and try not to drink the night before so you're not kind of shaky. You really want to have steady hands. I'm not to say you're all the type of people who are going to shake if you're not drinking, but I mean, or if you drank the night before, but But you really want to make sure you're well hydrated. You want to make sure you got electrolytes. It actually makes a difference. It really makes a difference. You know, some people come into lab and they're dehydrated, low on electrolytes, and they're just shaky, and it's very tough for them. So make sure you're in good health and good spirits when you come and do this lab. Okay, so we put that component there. My focus isn't looking too great here. I don't know if I can. Let me just tell my phone to focus on the board here. All right, so let's see what we can do. Let's hit it with a hot air, see what happens. It's looking pretty good so far. It's smearing out. See how it just kind of smears out everywhere? Smears out at first. And then once it evaporates, whoa, you see it pop? Did you see that? That's the miracle of solder. It's a miracle of solder. Now let's take a peek. Let's take a peek. So what do we got? Actually, wow, I think that could be good. I think that could be good. I'm a little worried about that pin that didn't have solder, though, because it might still not have solder. Actually, I don't know. That could be good. There's too much on the right side, but let me take a peek under the microscope really quick. Yeah, I don't think that left side. I'm a little worried about that left side. I'm not sure it's good. So, you know, it's okay. We can easily clean this up. So we can easily clean this up using an iron. All we have to do now is just come in here, add some flux. There's usually not a whole lot of flux that's built into the paste, so I'm just going to add some flux here, and then we're just going to gently rake the iron across these leads. And now I shorted this a bunch. So now let's clean the iron tip off. Clean the iron tip off on a wet sponge. Tends to kind of pull some of that solder off too. See how we're looking now on that right side. We got a bridge on the right side now. Oops. So now I bridged it. So I'm not going to worry about that right now. Let's do the other side though. So again, just raking, just gently raking. We don't want to use a lot of force. A lot of students come in here and they attack the component with the soldering iron. You don't want to do that. Just gentle motions. Let the heat, let the wet solder, let the heat do its thing. So that's looking good on that side. The other side has that bridge. So, you know, we can keep playing. To get this bridge, we can keep playing with it if we want, or we can just use that flux here. So we can just use this. So let's just get a little melty. Suck a little flux off, or suck a little solder off. Rake it again, just gently rake those components. And then how are we looking? Look at that. Very good. Very good. Okay. So I'm feeling pretty good about that. A lot of students worry after they use the braid that they've taken too much off. And usually a couple extra rakes with the iron tip kind of redistributes it. But it's usually underneath the pin, it's still connected typically. So now I have kind of a lot of this goop. I have a lot of this no clean. Now again, this is no clean flux paste, but it still is going to leave this little gel. It's going to harden and it's going to be fine when it gets cool. But it's still going to leave. It's going to leave that little dome around it. We can clean that up if we want. We can just get a little alcohol and clean that up, or a brush. Let's do a brush. So that's the price we pay for using a lot of flux. Is sometimes if we want to get it clean, it's kind of can take a little while. So now that's looking pretty good for that component. So that's looking pretty good. All right, that was the flux paste approach. Now let's do the battery charger chip. So the battery charger chip is a 5-pin chip, which means orientation is easy. We don't have to look for a pin 1 as long as it's not upside down. So we know as long as it's not upside down, the orientation because of that missing pin here. So oops. Okay, so I'm just going to set that in place. Oh, you can't see it. Look what I did. All right, kind of set that in place. And how are we going to solder this with the iron? I'm going to do this one with the iron. So they always say, you know, with soldering irons, apply solder. You know, use the iron to apply heat, then feed in solder. Okay, sometimes you got to cheat a little bit. Sometimes you got to put a little bit of solder applied to the tip of the iron. And now I'm goobering this whole thing. You know, I should have just put this on before I put the chip on. So put the paste on there. Make sure it's not upside down. I'm making a mess. And you know what? It's going to be okay. Okay. So, you know, yeah, they always say, yeah, don't apply the solder to the iron. Always use the iron to apply heat and then feed the solder in. Okay, but sometimes you got to get a little. Sometimes you got to get a little on the tip of the iron. So I'm going to put just a little bit on the tip. Got that little ball there. We kind of want to work fast because this is oxidizing as it's going. So now I'm going to use the tweezers and I'm going to hold this chip in place. And I'm going to solder one pin. Boom. So I'm going to get one pin soldered. I can't really even see because I'm trying to film this while I'm doing it. I can't see if I did a good job or not. But getting one pin soldered. Oh, look at that. 2 for the price of 1. Basically, that will give us our mechanical connection. So now this pin's not going anywhere. We got one pin down, two pins, I guess. Now we're going to go back and we're going to solder the rest. And we can do this the more traditional approach. So apply heat with the iron, feed in, solder. Give it a little rake. Feed it in, give it a little rake. Okay, so now that backside is nicely soldered there. So now both sides have a mechanical connection. So now we can go in and resolder the side that we kind of goobered up initially. And I think there's enough solder there that I'm just gonna kind of keep raking all these pins, just gently, kind of just pulling solder from one, redistributing it to the other, like a little bucket brigade here. Just gently pulling it. And then look at that. Is it still shorted? Is that just glare? Yeah, it looks like it's still shorted. No, I think it's good. Nope, still shorted. Is there a reason that's still shorted? I think what's happening is those pins are, I think they're actually shorted on the board, and that's why I can't get rid of the short, because it cut through. If you want to find out, let's get another blank version of my board. So, nope, those pins should not be connected. Those pins definitely shouldn't be connected. Those are battery positive, battery negative, so yeah, we definitely don't want those. So, you know, maybe it's just there's too much flux, so maybe I come in with the braid. My braid, I kind of used a lot of the end of that braid up, so snip, snip. Hit the new stuff with a little flux. Hit it with the iron. Now we're in business. Yeah, now we're in business. Okay, that one's looking good. All right. trying to think if there's something else I want to do for now. All right, let's say we got these components on. We want to do a different type of... Let's say we want to solder a resistor on with... so let's do that R4 really quick. I'll be right back. I think R4 was the current control resistor, so I think that was a 10K. So let's just do this. So I'm gonna get a 10K here. Okay. And we'll do R4 by hand. So to do R4 by hand, see my tweezers are getting sticky. So when this happens, my tweezers get sticky, clean them with alcohol. Means I touch too much flux or something like that. Clean them with alcohol. Let's get some flux on R4. And I just smeared it everywhere, and that's fine. So now once again, take our soldering iron, and I'm going to cheat, and I'm going to put a little bit on there. Get a little bit on the tip there. Take my part. Arrange my part as needed right here. Hit one side of it with the iron. Pull it back, let it cool. Let's look at that. So now we soldered, oh come on now, we soldered one side of it. All right, we got one side, now it's got a nice mechanical connection there. Now we can come in and do the other side. I don't know where my solder wire went, so now we can come and do the other side here. Now the thing with these surface mount resistors, if you're doing them by hand, is if you get solder on both pads, it can be very difficult to get this flat. So you want to usually keep one pad dry, solder the other pad, get it so it's on there nice and flat, and then come in and hit the other side with the iron. Now you can see this is covered with a lot of flux, a lot of goop. So if we want to clean that up, we don't usually have to clean that up. It's not hurting anybody. But if we want to clean it up, hit it with a little goop, hit it with a little alcohol. Give it a little scrub. And then clean up our mess here. Okay. It's looking very good. You know, maybe I'll do one of these op amps. So let's do an op amp with paste. There's one more example here. Everybody likes examples, so I'm gonna be really sloppy with this. You're definitely gonna be able to do a better job than me. Just really sloppy, smearing the paste on there. Actually, that was pretty good. So I just smeared some paste on there with a needle. It's probably too much. It's definitely too much. And because I didn't plan to actually do this in the video, I'm going to go grab op amp. You got a big reel for this op amp, right? Big old reel here. Maddening. Peel it back. Up and down. There it is. Put it back. Okay, So now with these, we can see on our board here, the pin 1 dot. Where's the pin 1 dot? Oh my gosh. Did I cover it up with the paste? Yeah, I think I did. So it's got to be back here. I got to clean my tweezers after this, but it's got to be back here. Yeah, it is. It was hiding back there. There's the pin 1 dot. And if we look at our op amp, there's no pin 1 dot on here. Oh, there is. Look at that little faint dot there. Can you see it? You see that little dot, little black depression in the... Let me change my light here. Yeah, you see that little circle, little black circle? So there's our pin 1 dot right there. Okay. So now I rotate it a little bit. So now pin 1 is that top left corner. I'm going to put it on here. Give it a little tap. Give it a little tap. Now it's kind of misaligned here. Yeah, I'm going to leave it misaligned. We'll see how the hot air does with this. Hit it with the hot air. Kind of working our way around here. And again, it's evaporating off some of that flux, and as soon as that flux gets evaporated, then the temperature very rapidly increases. So we don't want to leave immediately when we see it get melty. We want to give it a little extra time to make sure everything's melty. Okay. Now again, don't you immediately touch your board. How are we looking? Looks like we got some bridges. Do we have some bridges? Actually, no. They should be good. Those kind of look like bridges. I don't think they are, though. They're not bridges, but they're little balls of solder in there, which kind of bother me. So we'll clean them up. So they're little balls of excess solder in there because we use too much. So it's not actually bridging, but it's close enough. So fix it, flux it. Then clean that iron tip off. Rake it gently. Gently rake it. We're kind of feeling for that solder to be melty and slippery. And then now look at it. Much better. Much better. Looks very good. We'll just hit the other side for good measure. Beautiful. Beautiful. Okay. And now you can see also with us trying to get the iron in here and stuff, that's why we don't put the big components on. If we had those big components that were sticking up, we always want to do these little difficult ones first, then come in and do the other ones. And I'm kind of taking a long time. So if you're worried about how long this is going to take you, it might take you a while. You might want to prepare ahead. You're also going to be sharing iron. So basically you're going to have a couple irons in each lab. You're going to, at your own station, COVID isolated or whatever, do your paste, put your components on, then walk over with gloves to the solder station to pick up to use the hot air to reflow your part. So you're going to be doing a lot of, and you can do more. You don't want to do it one at a time. You're going to do, you could do all of these at once with the paste, then hit them with the hot air, then hit them with the solder iron if you need to. So your process should be quite a bit faster than mine. I'm kind of going slow trying to explain this. I want to talk about one extra thing before we leave, and that is your connectors to your sharp sensor. So when you get the connectors to your sharp sensor, they're going to look like this. So it's going to be this cable assembly with these loose wires, and these are loose wires. So these have to be fed through the holes, and the problem with loose braided wires, feeding them through holes, is it's really easy to have one little piece of the wire stick out and just kind of be a little booger and kind of shoot off to the other side. So I always like to tin these before putting them through the through hole. So what I'm going to do is show you. I just like to take them all, hit them with a little flux, and then for me, I like to, when I say a little flux, I mean a lot of flux. Then I like to get, oh, we can even set it down here. I'm just going to tin these. So I'm going to basically, we call it tinning, but it's basically just taking these loose braided wires and feeding them some solder so that they're kind of bound together. So they're sort of, so I'm just kind of brushing these. I don't want to solder them together. Okay. So now what I've done is now these aren't really loose anymore. So now these are sort of, they're coated with, so there's no loose braided parts anymore. So now what we're able to do is we're able to making sure these are oriented right before putting them in. They're kind of sticky. I probably want to clean these off first. So now we can kind of feed them through the holes, and as we do, we don't really have to worry about these braided sections. We don't have to worry about the braided wire getting loose on us. So see, they just pop through the hole. Then we can come in here and solder the backside. So, and again, you kind of need 3 hands for some of this stuff. So it's okay to cheat a little bit. It's okay to put a little bit of solder on the end of the iron. Just be careful, right? You don't want to burn yourself. It's okay to get a little solder on the iron here. Oops. So we got a little ball of solder here, and then oops, I think I was pushed in too. I had it pushed in too far. I was trying to solder the sheath to that. So just put it in part way, like that. Hit it with a little solder. Boom. Nice through-hole connection. And we could have fluxed that. I probably should have fluxed that. There was still flux on the wire though. So then I could feed the next one in. Next wire in. Now that one's done, right? So, and we do that for all of them, and then, well, let's make sure I'm not doing this backwards. Huh, I did. So this is actually backwards. It needs to be the other way. Easy enough. So just apply heat while giving the wire a gentle tug. Pop it through. Apply heat while giving the wire a gentle tug. Pull it through. Now here's what happens. Typically with these through holes, after we desolder them, it fills up. There's a couple things we can do. One thing we can do is we can go back to our old friend, clean that tip. We can go back to our old friend, the solder braid. And we can flux solder braid. Usually, if you're trying to pull a bulk of solder, you usually want to use a bigger solder braid than this. Apply that on here. Apply a little heat. Let's watch that solder crawl up the braid. Oh, didn't quite get it all. Look how far that solder's crawling up the braid. Still didn't get it all. No, that's all right. This is a fine solder braid. We shouldn't really be doing this with it, but I can get a coarser solder braid for this. Let's just get this. Dang, there's so much solder in this thing. See, and again, that solder would much prefer to be in the braid than to be on the board. So look at that, got it clear. So try not to do that because it's kind of wasteful of solder braid, but so be more careful than I was. But so this needs to be oriented this way. So it needs to be oriented this way. So this one should have been the one that went through the hole. This one should have gone through. There we go, right? So then we just repeat that. And so you can see the second one already has solder in it still. So the second one's still plugged. We didn't desolder that one. I can still probably poke it through. So I can still probably get it, sort of get the wire centered on this side, applying a little bit of pressure, and then melt the other side. Get the wire in the hole on the other side. Apply a little bit of pressure. Get the hole all melty. Yep, and push it through. So even if you don't clear the hole, sometimes you can kind of force it through. Not force it, you can still melt it and just sort of slide it through all melty. Okay. All right, so that's all. The rest of it, the rest of these components, are, the through-hole ones are typically easier. I'm going to leave it there for now, and we'll call that good for the soldering video. Thanks for watching.